Guys, we have this question right here. It's asking, is the set is linearly independent? Justify your answer. And the second question is, find the basis for span S and where S is the same as part A. And third one is S the basis for R3? Justify your answer. Let's begin with the first one. So first of all, if they ask if it's linearly independent, for the first thing we have to do is we have to arrange this in a we have to do Gauss Jordan. So before that I have to arrange every row. This is each of them are going to be a row, so it's going to be 1 2 minus 1 2 4 1 and 5 10 minus 2. So this is my row, and if I do the Gauss Jordan for this one, I will get 1 2 minus 1 0 0 3 0 0 3. How did I get it? I simply multiply the first equation by -2 r1 plus r2, then this is going to be -5 r1 plus r2. If I do that, I will get this answer, and this means these two equations are like one of them can be cancelled by using -1 and adding. Like if you multiply -1 r2 by -1 and add it to the third equation, you will get 0 0 0. So it's going to be, the final answer is going to be 1 2 0. I have to bring it in Gauss Jordan. I did a Gauss Jordan already, so it's going to be 0 0 1, and this is going to be 0 0 0. So the step is, if you do r1 plus r2, and this is 1 by 3 r2 minus r2 plus r3. So this is how we get this one. So this is final Gauss Jordan format. So from this one you can see this has two leading coefficient. Two leading one, it means we can call it p vector. So it means two leading one, and we have three vectors. So the rule is, if you if something's to be linearly independent, number of vectors should be equal to number of pivots. In this case we have only two pivots but three vectors, so therefore this is not equal, therefore this is not linearly independent. So this is the answer for the first question. And the second question is asking, find the basis for span S where S is the same as part uh, part uh, part A. So it means basis of spans means the thing that are remaining. This is going to be these two are going to be my spans, the two with leading coefficient. So I have to write those true rows. So basis of spans are going to be equal to 1 2 minus 1, and the second equation is 2 4 1. So this is my basis of spans. The third question is S a basis of R3? It's not a basis of R3 because in order to be basis of R3 it must contain three independent vectors, linearly independent vectors, but in this case we only have two right here. We solved it and proved that it only has two. It means that the other one is not the third one is not a linearly independent. So we have only two, which means this is not R3. So that's my final answer. You can just write it in birdie. So I hope you guys like this video. See you next time.